Okay, we are going through the topic of statewide counting programs. Okay, and they are done for the entire country and for the whole year. And we have seen some examples in which we calculated the adjustment factors. And the adjustment factors can be for different days of the week or they can be for different months of the year. And we did both types of examples. Okay, and there was one example in which we did both these things. Now, once you have the adjustment, and then we looked at one more thing about the adjustment factors, that if you have multiple control counts and each control count has its own adjustment factors, you can take an average and try to combine them. Okay, and there was a criteria for combining them, that the difference between the factor and the average should not be more than plus minus 0.1. Okay, so we looked at this example. We were trying to combine 4, but when we checked the difference between the average, it was more than plus minus 0.1 for, especially for 0.4. So we took 0.4 out of the group, and the remaining 3 points were fine. Once you have the adjustment factors, what to do with it? Why are we calculating the adjustment factors? So we have control count, for which we already calculated the AADT. For the adjustment factors, we already calculated the AADT. So control count is not my problem. My problem are other points in the same network. Okay, in the same network I have other points which are coverage. So on coverage, I cannot calculate AADT because I do not have complete data. Okay, coverage points, coverage counts don't have complete data. So how to calculate AADT for coverage then? This is where you will need the adjustment factors. Okay, so for example, you took coverage count for a point on one day. Now, one day cannot be AADT, right? It's a particular day. So AADT means what? Average annual, right? So it's the whole year. I need the whole year. But using the factors, I can even convert one day of count into the AADT, multiplying with the factors. You multiply with the factors of the day and the month. How? The table shows you adjustment factors for a control count location. So there was a control count location. I took the AADT, I found the AADT, and I calculated the adjustment factors like we have done before. These are the adjustment factors. In the same network, on the same type of highway, I had a coverage count, okay, for which the data is given in the last sentence. Okay. So when was the coverage count taken? When was it taken? Tuesday in July. One day, right? Only one day. Only one day of Tuesday. Oh, sorry, only one day of July. How do I convert it into AADT? So I will take 1000. 1000 is on a Tuesday, right? What is the adjustment factor of Tuesday? Tuesday, this one. Okay. And which month? July, right? It's taken on July. So what is the adjustment factor of July? 0.913. Okay, so this will become my AADT. How much is this? Huh? Clear? Okay, so this is how data of one day became the data of the entire year. Clear? Okay. We have talked about VMT earlier. VMT. So what is VMT? Tell me. What is VMT? V stands for what? V stands for what? Vehicle miles traveled. Okay. So I need the count and I need the length. Okay. I showed you an earlier example where VMT was calculated for 8 hours. 8 hours. Okay, so this was VMT of 8 hours. Now they are asking for VMT of the whole year. Okay, so I need the count of the whole year. I need the count of the whole year. Now you look at this equation. I have AADT, right, which is average annual, multiply by length. So it will become what? VMT, right? Count multiply by length, VMT. VMT for how much time? 1 day, because this is average annual daily. AADT is per day, right? AADT is per day. So you multiply by length, it becomes VMT of average VMT per day of the year. And then you multiply by 365. So it becomes what? 1 year. Clear? Okay. So you have the count, average count of the day, multiply by length, it becomes average VMT of the day, multiply by 365, it becomes for the whole year. Clear? Clear or not? Okay. Now, in this example, they have taken data from 6 stations. Look at the table on the left hand side. We have data from 6 stations. For each station, I have the length, and I have the day and the month in which count is taken, and the count is given in the last column. Okay. These 6 stations are on a specific type of highway in the same network. On the same type of highway in the same network, I had a control count, and for the control count, I calculated the adjustment factors. Okay. Now I will, for these 6 locations, I will calculate their total VMT of the year. For these 6 locations, I will calculate their total VMT of the year. So what is the first thing I need? AADT, right? How do we calculate AADT? This multiply by what? Adjustment factor of Wednesday, adjustment factor of March. Clear? It will become what? AADT. Multiply by length, multiply by 365. Got it? Clear? Okay. Let us do it. Okay, so station 1, 2, 3, 4, 5, 6. I'll calculate its AADT first. Okay, for the first station, the count is 9120. It's taken on Wednesday. The factor for Wednesday is 1.108. In March, the factor for March, let me make it bigger. Where is it? 1.1. Okay, so my AADT is how much? 1115. Okay, got it. Okay. Second one, the count is 10,000 something, and multiply by Tuesday factor and September factor. How much? One zero one six two. Okay, third. 1. Next. One three nine 138 13989. Okay. Now for VMT of the entire air, first of all I will take this value, multiply by its length. The length is 3 miles, multiply by its 365. Okay, so 365. Okay, now give me big numbers. So we did this. Yeah, how much? 121 709 25. Okay. Next, you will take the count from this column, length from here, and multiply by 365. 1001651. Next. Next. Two seven four. 5. Okay. So I had the count of only one day for 6 locations. I converted that into the whole year. So you can see the benefit of having the adjustment factors. Okay, I took the full count of 1 point and now it is serving 6 other points to give me the full count. Okay, so I found the AADT using the adjustment factors. Then I multiplied AADT with the length, it became VMT for 1 day, average day, and then I multiplied by 365, it became for the whole year. Any questions? Clear? Okay. Now, which section has the highest VMT? Section number 4. So it means what? Section number 1 has what more than others? VMT shows what? Why do we calculate VMT? Number of vehicles is more? VMT shows what? Number of vehicles are more, and also the length is also more, right? Okay. So length plus number of vehicles combined, they show what about the segment? Why do we calculate VMT? What is the reason for calculating VMT? It gives us what? It's an indicator of importance of the highway. VMT is an indicator of importance of the segment. So the most important segment is which one? Number 4, the one which has the highest VMT. And why it is most important? Because you can see the reason now. It is used by more people and it is providing us more coverage, connecting more areas. Okay? Any questions? Okay. Then we have specialized counting studies. In specialized counting studies, we are interested in demand of an area, not a segment, not network, not an intersection. I'm interested in finding out the demand of the entire area. Okay? So there are 3 specialized counting studies listed here. There can be more types as well, but we only discussed 3. But the common feature in all of them is we are trying to find out demand of what? An area. Demand of an area. So we'll discuss the first one, which is the origin destination counts. Origin means what? The word origin means what? Huh?
The point where we start.
Start point, right? Start point. And the destination means? End. Okay. So this is a study about start and end. Okay. But what do I say about specialized counting studies? We are interested in demand of area. So not start and end point. Start and end areas. Okay. I'm interested in finding out how many trips are starting from the area and how many trips are ending in the area, not points. I'm not looking for a specific point, I'm looking for the entire. Clear? There are 3 methods to do origin destination studies: license plate, postcard, and interview. In license plate method, at each entry and exit point of all the areas, I place observers who are writing down the license plate numbers of the car entering and exiting. Okay? In license plate method, I have observers. They are at the entry and exit points of the areas, all the areas. We call them zones. So at all entry and exit points of all the zones, I have observers, and these observers are writing what? License plate numbers. Okay? When the study is finished, they will take their data to the office and match the data with each other. So maybe person A will say, I saw this car leaving this area. I noted down this car leaving this area. And person B will say, I saw the same car entering this area. So the area from which it came out becomes the area from which the car came out. It becomes what? It's, we are doing origin destination, right? So the area from which the car comes out becomes what? The origin. Okay? And the area in which the car goes in becomes what? Destination. Clear? Okay? So we have the license plate numbers and we know whether the car was exiting or entering. So you match it. The car was exiting, you say this is the origin, and if it was entering, you can say this is the destination. Got it? Clear? Then we have the postcard study. You guys haven't seen the postcard, right? Don't know what is the postcard. Or do you know? No. Okay? You are a digital generation, right? So, now we have some other things. Anyways, a postcard was a card, a small card, on which you write some message or questions. In this case, you will write questions. Okay? And the question, the 2 main questions: what is your origin area? What is your destination area? If you are interested in some more information, you can include. But it's a small card, keep it in mind. It's a small card, not bigger than your phone. Okay? So it's a small card. So you cannot write many questions. 2, 3, 4 questions, that's it. But 2 questions are: what is your Origin, what is your destination? Clear? You distribute these cards. Okay? You distribute them and you go home. You can distribute them in parking lots, you can distribute them on signals, okay? Wherever you have the chance, you can distribute them in the travelers directly. The travelers, whenever they get a chance, they will fill the card. On the back of the card, there used to be an address. Okay? So they will fill the card and they will post it. So that's why they are called the postcards. Okay? Now we don't have to do this, right? We don't have to do a physical card. You can just give them a QR code, scan it, answer the questions, and you will get the answer, right? Becomes easy. You can still give them the card, but the card may not have the questions. It may just only have the QR code or WhatsApp number or email, whatever. Okay. So it will directly get the response in your folder. Clear? Okay. So we can make digital postcards. Okay. But you get the idea. We distribute them to the travelers, they will fill it and you will get the response. Got it? Clear? We are not doing observation on the road. Okay? We are getting the answers from the travelers. Then we have interview studies. Interview studies have more questions. Interview studies are more detailed. It has more details. You are asking more information. Okay? So the difference between postcard and interview, the main difference is the amount of information. So interview studies are never done only for one purpose. So I need information for many things. Okay, I am doing economic survey, a transportation survey, a household survey, different things. Okay, so I will combine information required for all of them into one interview. So I don't have to go again and again. Okay, so it will be a big questionnaire which is asking them about everything. Members in the household, how many cars, trip, origin, destination, trip cost, trip time, okay, and so on. Income, age, gender, everything. Got it? Okay, so it's more detailed. Since it is more detailed, you cannot leave it up to them. You cannot just give it to them and ask them to fill it. It's not efficient. Most of them will not do it complete. They will get bored and they will just finish it. Okay? So we go and we ask the question, we write the answer. Like it's done face to face, person to person. Okay, one on one. Clear? This is the first difference between interview and postcard. Now, can you do this on the road? Interview studies, can you do this on the road? People who are still thinking, don't. Okay, some of you are still thinking, no, we cannot. Okay, don't try. Okay, so where can I do these interviews? So postcards, I can just distribute them, right? They are standing on the signal, waiting for the signal, I just give it to them. Interview studies, where should I do them? It cannot be like this.
For example, in the malls.
In the malls, where they are wasting their life. Yes. Where else? Parking lots, okay. Houses, okay. So these places where they have more time, they can settle down and answer your question. Got it? Clear? Okay. So these are the three methods. In the first method, you are doing the observation yourself, and the matching of the data will give you the number of trips. And then the next two methods, you are asking them. Okay? Yeah. So from any of these methods, you will get the data, and then we prepare a table which you see on the slide there. It's called an OD matrix, origin destination matrix. Okay, an OD matrix or an origin destination matrix. So your entire area in this example, this is an example. This is an example. So your entire area is divided into 4 zones. Okay, you can see the zones here. And the same are mentioned here. How many zones we have? 4. But this is just an example. It can be more than 4 or less than 4. It is up to you. You look at your region and you see how many zones you want. There are some guidelines, but it's not a fixed number that every time we have to make 4. Got it? Okay, it can be any number of zones. Clear? So you see the zones are mentioned as destination and the same are mentioned as origin, because one area can be an origin for somebody and can be a destination for someone else, right? So the area from which you came, maybe somebody was going in there, right? Okay, so the same area can be origin or destination. Okay, then you see the numbers in the matrix. So each number is showing the combination, right? Combination. What is this 50 showing? Their origin is what? Area 1. And their destination is what? Area 1. Okay, happy people, lucky people, don't go anywhere. Go out of their house. This is my school, this is my cold store, this is my mosque, this is my university, this is where I work. Everything in the same place. Okay? This is why I said, shift your house. You don't get stuck in traffic. What about these 8? They are coming from which area? 2. They are going into which area? 1. Clear? Okay? Got it? Then for each column you see the summation. Okay? So all of these for origin 1, all of these for origin 2, and so on. Got it? Then 95 for destination 1, 106 for destination 2, summation of rows. Got it? Clear? Then you see some other numbers. These numbers are counts which are taken from the field. Now what happens? If you are doing license plate, nobody can write all the license plate numbers, right? You will miss some values. You will miss many cars actually. Okay? If you are doing postcard, not everybody will return your postcard. Not everybody will answer your questions. In the interview studies, the questionnaire is even longer. So even less people will answer you. Okay? So the data which you collect from any of these methods is not the complete data. You have missed a lot of people. So it's just a sample. The numbers which you see in the matrix is just a sample. Okay? So I have to do some adjustments to make the sample complete. To fill the missing values, I have to do some calculations. Okay? So, some adjustments. For doing these adjustments, what did I do? I took a count from the field. So I put observers on the entry and exit points of the areas, and these observers were counting how many vehicles are entering and how many vehicles are exiting. So for example, look at the first column. The number is how much? 210. 210 vehicles were coming out of area 1. Okay? Next column, 200 vehicles were coming out of area 2. Look at the rows now. First row, 250 vehicles are going into zone 1. 310 vehicles are going into zone 2. Got it? Okay? So your field count is showing these values. And your matrix, is it showing the same values? No, right? There's a difference because the matrix is a sample and the field count is complete. Okay? So I have to make the matrix equal to the field. I have to make the matrix equal to the field. For that we will calculate factors for each row and column. Adjustment factor for each row and column. How do I do this? Take the first column. Okay. How much is the volume? So I will call it F1, whatever. Okay. What is the volume for the first column? How much is the volume? 210. What is the summation from the 88? So this is my adjustment factor of the first column. Got it? If I want to do it for the first row, so I'll call it F1 dash. What will I do? What upon what? 250 upon 95. Clear? So for each row and column we will do this. Okay? Okay? So you see the factors over here. These are factors I will show. Clear? Each factor is volume upon sum, volume upon sum, volume upon sum. Clear? Any problem? Now what to do with these factors and the values in the matrix? I'll pick each value from the matrix, okay, and multiply by the average of the factors for that row and column. Okay, for example, 50. Now look here, the first value is how much? 50, right? Okay, what is the factor for the first column? 2.39. What is the factor for the first row? 2.60, 2.39, 2.63. So 50 multiplied by 2.39 plus 2.63 divided by 2. Okay, so you will pick the number, take its factors, do their average and multiply with the number. Okay, the answer will be the number in the new matrix. You see the first value is how much now? From here, 125. Got it? Clear? Okay. Now what? Tell me about the second value. Second value is how much? 8, right? 8 multiplied by what? Tell me. 2.02, 2.63 divided by. Okay? Clear? So whatever the answer is, 8 will be replaced by that answer. Okay? And the answer in this case is almost 19. Got it? So this entire matrix will change using the same calculation. The entire matrix will change. Okay? The new matrix, right? This is now the new matrix. Okay? When you change the values, the summation of rows and columns will change, right? So now we have the new values and the new summations, right? For each row I have a new summation, for each column I have a new summation. Okay? Okay? Volume. Will it change? Volume will not change. We did not do anything in the field, right? Volume came from the field count. Did we do another field count? No. So the volume will remain as it is. But because the summations changed, you can recalculate the factors. So now I have new factors. Okay. So how did I get 0.9 here? First column, 210 divided by 230. Got it? Okay. Tell me, factor for the first row. Factor for the first row, what? What upon what? 250, the volume upon 267. How much is it? Huh? 9. Okay, got it. Clear? Now I'm trying to make them equal, right? I'm trying to make these two things, volume and the summation, equal, right? My sample should be complete. Volume is complete. I'm trying to make the matrix complete as well. So they will become what? Equal. So when they will become equal, their ratio will become what? Huh? Their ratio will become what? 100%, meaning 1, right? The ratio will become, we are not calculating percentage. You say percentage, I will say percentage. All of them will start calculating percentage. Okay. So their ratio will become what? 1. Okay. Look at the new factors. Are they 1? Are they 1? No. Okay. So we will do what now? We are trying to make them 1. They didn't become 1. What should I do? I do another trial. Same procedure. I do another trial. The same procedure. Now I will use the new values and the new factors. Okay. So now I will try to change, for example, 125. 125 multiplied by what? Tell me.
11.9 plus 11.9 plus 11.
Okay. You take the values from here and you take the new factors. Clear? And again, you will do this for the entire matrix. For the entire matrix will change, and this is the new matrix now. Once you have the new values and the new matrix, again you will recalculate what? The summations. When you have the new summations, you will have the new factors. Okay? Now these factors should be what? How much? 1. Okay? 1. Now to make them exactly 1, it will take lot of iterations like this. Okay? So we are human beings, we are not looking for perfection. Okay? So you guys are not looking for A as well, right? Some of you will be happy with B and C and D and so on, right? Human nature. So we are not looking for perfection. So I am not looking for exactly 1. I have a range. If the values are in the range, I am okay with it. What's the range? 0.9 to 1.1. If the factors are between 0.9 and 1.1, all of them, then I will stop my iterations. Otherwise, I will continue. Clear? Okay, look at the factors. Can it be my last iteration? Can it be my final answer? Why? Because I have second column which has 0.87 still. Okay, so I will do another iteration for the entire matrix. This is the second one. This is second one, and then I will do a third one as well. Okay, I did 2 iterations, I got this. Okay, and still it has a problem. So I'll do another one. Okay, using the same method, and this is the new matrix now. Okay, now look at the factors again. Numbers will change, sum will change, and the factors will change. Look at the factors now. Can it be my final answer? Yes. I can stop here. Clear? So this is my final origin destination matrix. Clear? Okay. Any questions? Okay. So we did not do it, so I would say that you practice. Okay, take the matrix and do it yourself. Okay.